All right, so when we're looking for vertical asymptotes, first you're going to factor the numerator and the denominator. You're going to cancel any common factors that you see on the top and bottom, and then you're going to set whatever you have left in the denominator, you're going to set it equal to 0. So the first step is to factor the numerator and the denominator. So when you're looking at x minus 10, that does not factor any farther, so I'm just going to write it down again. Then we're going to look at the denominator. All right. You always look for a GCF first. You can actually divide both terms by 2. So we're going to pull out that 2. So 2 is a factor. Factors are the things that you're multiplying together. So just to remind you, factors, like here's a factor and this will be a factor. If you multiply these two factors together, you'll get what you started with. So both of these can be divided by 2. So since I pulled that 2 out of there, I'm going to go up here and I'm going to divide them by 2. So if you divide this one by 2 and then divide that term by 2, you're going to get an x plus 5. You can check this if you come down here and do destroyer property. 2 times x is your 2x. 2 times 5 is your positive 10. So after you factor, you should always go back and multiply those together to make sure that you get what you started with. All right, now when you look at the numerator and you look at the denominator, they don't have anything in common. You cannot cancel the x's. You can't cancel this 10 and the 5. You can't cancel that 10 and the 2. This right here that's in parentheses, that is a number. It is whatever x minus 10 is, that's a number. And this is x plus 5, that's a number. All right, if you plug a value in for x here, you'd have to plug in the same value for x there. And when you do that, you're not going to get the same thing. So they do not cancel. All right, so we did step 1. Step 2, there are no common factors to cancel out. So then step 3, all right, step 3 is to set the denominator equal to 0. All right, so when we're looking at 2 times x plus 5, I'm going to write that down. So we have 2 times x plus 5. We need to know when will that equal 0, because we know that a denominator cannot equal 0. All right, we cannot have something over 0. So we need to figure out what value of x will make the bottom 0, and then x cannot equal that. So continuing, if you have two things being multiplied together, this 2, we would normally say, okay, we're going to let 2 equal 0, and then the x plus 5 equals 0. All right, well, we know that 2 is not equal to 0, so that's not even anything that we need to deal with. All right, but over here we do need to solve, and we find that x equals -5. All right, if we plugged a -5 back in here, we plug a -5 in right there, that will make this parenthesis 0, and 0 times the 2 will be 0 on the bottom, so it will not work. All right, so this x equals -5 that we just found, that is a vertical asymptote. Okay, so we have one vertical asymptote, and it is x equals -5. Now, a couple things you need to know, just in general, and you can watch the other video that I have. It's kind of the graphing video, just to see the big picture of what's happening. But x equals -5 is over here. So x equals -5, this line that I just drew, this dashed line, that is the line for x equals -5. And an asymptote means that our graph will get close to that dashed line, but will never actually touch it, okay? Because we know that we cannot plug a -5 in for x. All right, so maybe our graph will do something like this. Maybe our graph will do something like this. It will get closer and closer and closer to x equals -5, but it will never actually hit it. So that's what we just found. All right, in the other one, all right, so we are going to factor the numerator and the denominator. So in the top, x squared minus 36, that is a perfect square minus a perfect square. Okay, square root of x squared is x, square root of 36 is 6. If you have a perfect square minus a perfect square, that will always factor to its square root. Both binomials will have the square roots, the x and the 6. One will be plus and one will be minus. If you don't believe me, which you should always, when you write down your factors, you should always go back and double check. FOIL, first times first is x squared. Outer is negative 6x, inner is a positive 6x. Those cancel. That's why there's no middle term. And then last times last is a negative 36, which is what we have. In the denominator, we can actually factor out a 3 out of the entire thing. Do not forget to check your GCF, right? So you can go up here and you can divide each one of these terms by 3. Since we can do that, we factored out the 3. So when you divide all of them by 3, you're going to get x squared plus 3x minus 54. And that trinomial that I just wrote down, this can be factored farther. So the top is still an x plus 6x minus 6. The bottom, we have a 3, but then x squared plus 3x minus 54. This right here, it factors to x plus 9, x minus 6. Now, right here, we're going to see, because this is step 2. Do you see how these are identical on the top and the bottom? So those will actually cancel. Okay, so since they're going to cancel, I'm going to cancel those out real quick. These two cancel. So what you have left to find your vertical asymptote, you have a 3, or set that equal to 0. That's one of the factors. And we're also going to set x plus 9 equal to 0. All right, now we know that 3 cannot equal 0 no matter what we plug in for x. And when we solve x plus 9 equals 0, we find that x equals a negative 9. So in this case, there's also just one vertical asymptote, and it is x equals negative 9. So make sure, don't just put down negative 9. You need to put x equals negative 9 because this vertical asymptote represents a line. So we have to write the equation for a line. If you just say negative 9 and you're looking on a graph, well, there's a lot of places where you have negative 9s. Okay, you have negative 9 on the x-axis, you have negative 9 on the y-axis. There's a lot of negative nines, so you have to be clear on this. Now, just a little note, all right, that x minus 6 that we canceled out, okay, in case you're curious about that, the x minus 6 would actually create a hole, okay? So the things that cancel out, if you plugged in a positive 6 here, we would have gotten a 0. So if you plug in a positive 6 in for all your x's, you would get a 0 in the bottom, all right? So there's going to be an issue where x is 6 right there. So what will happen there is if you have a graph, okay, we know that over here at negative 9, we've got a vertical asymptote. Okay, we know that. But over here at 6, we've got something going on. So let's pretend for a second, I'm not sure what this graph is going to do, but let's pretend for a second that our graph does something like this. Okay, let's say that it does this. Now, since we have an issue where x is 6, there's actually a hole right there where x is 6. There's actually a hole right there. All right, so the graph, just for that one little point, that one coordinate, there really isn't anything there. Okay, you don't have to know that for the delta, but just sharing with you.